Lesson 7 is dealing with an application problem with a business. And the first part of the problem is really just going to be talking about total cost, revenue, and profit. And then we're going to get into how can we use a system of linear inequalities to help us understand the profit versus loss for this business. So in this problem, we have fixed costs for this company that are $70,000 and variable costs that are $8 per item. The difference in fixed costs means it's a one-time thing, where variable costs are going to depend on whatever um, the number of items we have, because it's $8 per item, so it's going to depend on however many items. And then the last part here says they plan to charge $15 per item. So that's going to be how much money they're going to be making is going to be $15 per item. So part A is asking us to find the total cost, revenue, and profit for selling X items. So the first thing we want to do is we want to let X equal the number of items. Since it tells us that we're selling X items, and our variable cost is going to depend on X, the number of items, and same with the $15 per item, that's going to depend on X as well. So the first part here is talking about the total cost. So the total cost, we're going to say, we're going to call that C of X for total cost. So C represents our cost. And when we do this, the total cost is going to be $8 per item plus the $70,000 fixed cost. So it's going to be 8 per X, which really means 8 times X, plus the $70,000 fixed cost. They have to always pay that $70,000. And then the $8 is going to depend on however many items they sell. So then the next thing that it asks us is for the revenue, so the total revenue. So total revenue. And revenue means the amount of money that you're bringing in. So revenue is however much money you're bringing in. So I have R of X for that. That's going to be however much money we're charging. So we're charging $15 per item. So that means 15 times the number of items. Per item means times X. So 15 times X is how much money that they're going to bring in. But if you want to know your total profit, so how much money did you actually make, well, you got to subtract off how much money you spent to produce these items. So the total profit is going to be, let's call it P for profit. It's going to be represented by however much money you made minus however much money you spent to produce these items. So it's going to be the revenue minus the cost. So it's going to be R of X minus C of X. We haven't talked about functions yet, so don't worry so much about this notation, but it's really just saying profit equals revenue minus cost. So then we actually have to go through and figure out what that is. So the profit equals the revenue, 15x, minus the cost, which I'm putting in parentheses so that I remember to distribute this negative. So I have an equation that I need to now simplify. So I have 15x minus 8x. So I'm like distributing this negative here. So 15 minus 8x is going to be 7x. And then minus the 70,000. So that's going to be my total profit equation. So now let's go back up to part B. It says if they sell 7,500 items, find their cost, revenue, and profit. So now that we have equations for all of these, and we know that they sell 7,500, this is going to be my x. So I'm going to take each of my equations that I created in part A, and I'm going to plug in 7,500 for x. So x equals 7,500. Okay, so we'll start with the cost. So let's plug in 7,500 for cost. So we had 8x, so 7,500 plus 70,000. And then you could just put that in your calculator and you should get 130,000. And then we'll look at revenue. So we're going to plug 7,500 in for x. So then we have 15 times the number of items sold, which is 7,500. Plug that into your calculator. You should get $112,500. And then the last one is the profit. So the profit, plug in 7,500. So we have 7 times the number of items minus the 70,000. And that'll get us a total profit of negative $17,500. So that is not a good thing, to have a negative profit, which means you're losing money. So if they produce 7,500 items, they're losing money. They're losing $17,500. So let's look at another situation, which is part C. What happens if they up that and they sell now 20,000 items? Is that going to help? Is that going to make their profit in the positive numbers where they're actually making money? So we're going to do the same exact thing that we just did for part B, but we're going to do it for $20,000. So we're going to let x equal $20,000 now, or not $20,000, 20,000 items. So we're going to plug in for the cost. So how much does it cost to produce 20,000 items? So we plug that in. So we have 8 times 20,000 plus the fixed cost, which was 70,000. So it ends up costing them $230,000 to produce 20,000 items. And then we're going to look at the revenue. So how much money do they actually make, or how much money are they selling these for? So 20,000, we plug it in for x. So $15 per the 20,000 items means that they're going to make $300,000, which hopefully you're seeing when you compare these two numbers here, that they're actually going to be making more money than what they paid, so their profit should end up being positive. So then the profit for 20,000 items is going to be 7 times 20,000 minus 70,000 using our formula, which ends up being $70,000, which you could have just looked at the revenue minus the cost, 300,000 minus 230,000, and you would have gotten the $70,000. So that means I need to at least sell 20,000 items so that I'm making money. But I'm assuming that I could sell less than 20,000 items and still make some money, which is called the break-even point. So we would want to figure out, well, what is the number of items that you have to sell to break even? So where your revenue and your costs end up being the same number. And then you'd want to make a profit, so you'd want to make sure that you sell more than your break-even point. So I'm assuming by the looks of it, I could sell less than 20,000 items, but definitely more than 7,500. So maybe somewhere in like the 10,000 to 15,000 range would get me a reasonable profit, um, where, I'm not losing money, but I'm making some money. So let's look at, that's actually what part D is asking you for. It's asking you for the break even point. So part D is asking for the break even point. And the break even point, like what I just said, is where your cost equals your revenue. So it's where you're not losing any money, but you're not making any money either. You're just completely breaking even. So if you want to figure out where that happens, what you would do is you would set your two equations equal. So I would set C of X equal to the revenue. And then once I see where those two things are equal, that will tell me what the number of items I'd have to sell to break even. And I would want to make a profit, so I would make sure I sell more than that. So the cost function was 8x plus 70,000, and the revenue was 15x. So now I just solve this for x, and that'll tell me how many items I need to sell to break even. So 70,000 equals 7x, divide 7, and I have 10,000 items would be the break even. So if the company sells 10,000 items, they're not going to make any money, they're not going to lose any money. It's the break even point. So you can write that. So 10,000 items is the company's break even point. So if you were running this company, though, you would probably want to make money, so that means you would want to sell more than 10,000 items. Otherwise, if you sold less than 10,000 items, you're going to be at a negative profit, which wouldn't be worth selling those items. If you go back up to parts B and C, when we were less than 10,000 items, which was in this case here, we had a negative profit. When we were more than 10,000 items, we got a better profit. So let's look at this on a graph so that you can kind of see how we can use linear inequalities to model this. So we're just going to do a rough sketch here. We're not going to worry about it being perfect. But basically, when you're looking at this, you would only be looking in the first quadrant, because on a graph, if you think about it, the other quadrants have negative values for x and y. And we're looking at x only in the positive numbers because we're talking about x equaling number of items. And you can't have a negative number of items. So we're looking at just the first quadrant for this. So this would be my x-axis and my y-axis. And if I look at graphing my two functions here, my two equations, so the cost equation was 8x plus 70,000. And my revenue was 15x. So the revenue is going to start at 0 for y-intercept, and I'm going to have a slope of 15. So it's up 15 over 1. So the slope's going to be relatively steeper than the other one. And this other equation here, the cost starts up at 70,000, so that's my y-intercept is up here at 70,000. So I'm just doing a rough sketch. I'm not worrying about this being completely accurate. And I know that my slope isn't going to be as steep. It's an 8 over 1. So instead of going up 15 over 1, I'm only going to be going up 8 and over 1. So my slope will be slightly flatter. And when I look at this, my slope I think is a little bit like my C of X. I should be a little bit steeper. I kind of made it more level just because I wanted you to see the intersection. But when you look at this, that break even point is right here. This is the break even. So what that means is that value, remember we just found, is 10,000. So when X equals 10,000, that's the break even point. So what happens for the inequality aspect of this is the areas of your profit versus loss. So when you are paying more, so when your cost is more than your revenue, so in this region right here, this represents the area of loss. Any number less than 10,000 for X is going to result in loss. So right here is going to be the area of loss. So that shaded area, when you shade below your cost function and above your revenue, in this region here is going to result in a negative profit. So your profit is going to be less. It's going to be less than, it's going to be a negative number because you're paying more than what you're making. And then on a positive side, though, would be in this region up here. This region is going to represent an area of profit. So up here is an area of profit because once you've sold 10,000 items, you're going to be making more than what you put in. So if you look, your cost, it's where your cost function is greater, and where your revenue is going to, or where your revenue is greater and where your cost is less, is going to be the area of profit. So it's where you're selling more than what you're paying to produce these items. So that was whenever X is greater than 10,000. So that's kind of how we're looking at, we're using inequalities because the only way to represent like a shaded region is to look at inequalities where, okay, my revenue is greater than my cost. So that's my shaded region.